adding and subtracting matrices. The basis of matrices is linear algebra, and just like ordinary algebra, matrix algebra has operations such as addition and subtraction. What we have to keep in mind is, as we learned previously with our rows of columns, we have to make sure we have elements that are consistent to add both together. I got a 2 by 3 matrix here at the upper left. And notice this is a 2 by 3. And I got another 2 by 3. I can add these two matrices up. Here's a 3 by 3, and that's subtracting another 3 by 3. I can add those up. What I cannot do is on the right here. I cannot add a 2 by 2 matrix to a 3 by 2 matrix. I cannot add a 1 by 3 by 2 by 3. Both, in other words, both my matrices, rows and columns, have to be the same to add or subtract them. And you'll see why in the following slides. There's 4 rules here. You can only add matrices same dimensions, i.e. those are the rows and columns, same rows, same columns. Our resulting answer will also have the same rows and columns as well. It also follows the basic properties of addition, the commutative property as well as the associative property. You can even add 3 sets of matrices together as long as they each have the same number of rows and columns each. Let's add these together. Now, I'm taking a slow by step by step. You might do this in your head. However, we have to have consistency here. I've got a 2 by 3 matrix here. This is 2 rows, 3 columns, and this is 2 rows and 3 columns. So I can add these together. And what I'm going to do, I got to add each element along the same lines. This is element 1, 1, row 1, column 1. Here's the row 1, 1. I only add those two together, and that's 1 plus 5 is 6. Here's row 1, column 2. That's a 2. Row 1, column 2. This one is 6. 2 plus 6 is 8. Row 1, column 3. Over here is 3. Row 1, column 3 is 7. 3 plus 7. In my second row, I've got column 1, 7. Second row, column 1 is 3. 7 plus 3. Row 2, column 2. That's 8. And then in B, row 2, column 2 is 4. 8 plus 4. And then row 2, column 3 is 9. And A. And row 2, column 3 in B is 5. So that's 9 plus 5. And 1 plus 5, that simply adds up to 6. 2 plus 6 is 8. 3 plus 7 is 10 down here. 7 plus 3 is 10. 8 plus 4 is 12. And 9 plus 5 is 14. And you could have just gone here. I know 1 plus 5 is 6. And 2 plus 6 is 8. But most importantly, what I want you to keep in mind here, and the reason I put all these together like this, step by step, is I want you to notice that I've got 2 by 3 here, 2 by 3, and a 2 by 3, and I added each elements by row and column together. And notice I still have a 2 by 3. Here is my first row. I put them all together. But it's basically got 2 rows, 1, 2, and then I've got 3 columns, right here, right here, and right here. And here's my answers. It's still 2 rows and 3 columns. Subtraction's the same way. If I want to subtract things, I do the same thing. I gotta make sure I have the same number of rows. Got 2 here, 2 here. Same number of columns. Got 3 here, got 3 here. So good. I am good to go on this. Let's erase those. And I'm doing the same thing as I did before with addition, so always subtraction. first row, first column, 1 minus 5. Second row, I'm sorry, first row, second column, 2 minus 6. First row, third column, 3 minus 7, right there. Second row, first column, 7 minus 3. Second row, second column, 8 minus 4. Second row, third column, 9 minus 5. And let's put it all together. 1 minus 5 is minus 4. 2 minus 6 is minus 4. 3 minus 7 is minus 4. 3 minus 3 is 4. 8 minus 4 is 4. 9 minus 5 is 4. And that is I'm subtracting matrix A from matrix B. Notice I still have 2 rows here and 3 columns here. And in the end here, I have 2 rows and 1, 2, 3 columns. Now, I'm looking at this here, and which statement is true? And I'm looking at A plus B equals C. Well, I know that's not true because this is a 2 by 1, and this is a 2 by 2. I can't add different rows and columns together. So I'm going to cross off anything with A in it. And that would, so I know that right there is not correct. And that means that one's not correct. Which here's a 1 here and a 1 here. So let's see which one is correct. B plus C equals D. 4 plus negative 1 is 3. 5, let's put these right here, make a little matrix. 4 plus 1 is 3. 5 plus 0 is 5. 6 plus negative 2 is 4. And 6 plus 0 is 0. 6. So that's 3, 5, 4, 6. So B is correct right here. Now the question is B plus C. Let's see. What did I do here? So that's B right there. B plus C equals D. That's not what we're looking for. B plus C. This plus this does not equal this. That's not D. So let's erase this. Remember, that's not 1 at all. And let's see what we can determine. My pen here, we know it's not anything with 1. So we just said B plus C, 4 plus 3 is 7. And I've got written down here, B plus, let's see, B minus C equals D. Let's see what I've done here. 3 minus 4 is negative 1. Here's my 3. Here's my 4. And these are all 2 by 2 matrices. That's why I said I know I can add them up. 2 by 2 and 2 by 2. 3 minus 4 is negative 1. 5 minus 5 is 0. Here's my 5 and my 5. 4 minus 6 is minus 2. I've done right here. And then 6 minus 6 is 0, which I've also written it down here. So B minus C is D. B minus C equals D. So the only, and we just know B, we just added B plus C. We didn't get that. So the only one that's correct is 3. Now, there's a couple other things I want to look at in terms of matrices here. Number 1, I've got, let's see, P, a 2 by 2 matrix, Q, a 2 by 2 matrix, and then R is a 3 by 2 matrix. I can type P plus Q. I'm just going to add 1 and 5, negative 1 and 5, 3 and negative 1, 6 and negative 2, and 0 and 1, which I've done right here. 1 plus negative 5 equals 4, or negative 1 plus 5. 3 minus 1 is 2. 6 minus 2 is 4. 0 plus 1 is 1. So P plus Q is correct here. Let's find Q plus R. Oh, we can't, can we? Why? Because this is a 2 by 2. Q plus R is 2 plus 2, and this is a or 2 by 2, and this is a 2 by 3. So I can't do that one. It's an indeterminate. And Q minus Q, this is an important rule as well. This is a rule of 0. If I subtract the same matrix from itself, I will get 0 in all rows and columns. We can also do a lot of basic algebra when we're determining. So we're talking about solving matrices. This is, once you start solving multiple equations, more than two, and even solving two equations with two variables can take a little work. Well, we can do three equations, three variables, four equations, four variables. It's a little tedious after a while, but if you know matrices on Microsoft Excel, you can solve it pretty quickly. And basically, I've got what I'm going to do. If I'm going to add these three matrices, I would do this. Let's see, this is, when I look at this here, A, B, and C. And what am I looking at here? I'm going to add 3 plus 3. That gives me 6. 2 plus 2 gives me 4. Now 0 plus Z equals 9. So that's interesting. And I don't know what it'll be, but we can technically do algebra and always do it in your head. If I know this first row and first column, equals this, and 2 plus 2 equals 4, then 0 plus C equals negative 9, which makes C negative 9. 0 plus negative 9 is negative 9. So we just did some basic algebra using multiple equations right here. Let's do another one here. B plus 5 equals 20. Well, the only thing that could be B plus 5 is 20 would be 15. So B right here is 15. Notice I'm making, since we're adding subtracting, we're maintaining the same row and same column, not only in each of our variables, but also within our result. And let's see, here's the last one here. A plus negative 1 equals minus 2. The only one that could be is A could have me a negative 2, because negative 2 plus negative 1 would be negative 3, which is what we've done right here.